This is for Year 11 Specials. We're going to look at question 7, 8, and 9 from exercise 20D. Okay, so this exercise deals with vector projections or vector resolutes. So what's happening in question 7 is you've got two vectors, A, B, okay, and they're position vectors, meaning they start from 0, point 0, okay, that's important. And we're trying to find the vector resolute of A onto B. Okay, so what that means is you've got a vector A. Now, A's in this direction and B's in this direction, so that's vector B. The vector resolute is basically asking, if I were to break down A into two components, like if I were to go, okay, A could equal this across and this up, because it still gets the same point, right? So that's 0, that's origin. The component that's parallel to B, like as in the same vector as B except different magnitude obviously, will be called U, and the vector that's perpendicular to B, to OB, would be called W. So, and we know that the formula for U is A dot B, A dot B, B dot B, B dot B times the vector B. Okay, and I'll just write the tildes. So A dot B is 1 times 1, which is 1, plus 3 times 1, which is just 3, over B dot B. So B dot B, 1 times 1 is 1, 1 times 1 is 1. Okay, and then you're multiplying that by B plus J. Okay, so that's 4 divided by 2, which is 2, I plus J. Okay, so that's your vector resolute. Okay, that's the parallel component. Now, it says a unit vector through A perpendicular to AB. Okay, so what that means is through A, well, what that's saying is you've got the point A here, so right there at the top, and you've got the point B here. Okay, so you want A to be perpendicular to OB. Well, OB is this line over here, that's OB, and this is A. So if you want a unit vector that's through A and perpendicular to OB, it's essentially asking you to get the equation of that. Well, it's asking you to get W, okay? But not just W, it's asking you to get a unit vector of W, okay? So once you work out W, you just take the unit vector of it, okay? So it's a bit of a trick to decipher like what it's trying to ask you. So it's asking for the vertical component or the perpendicular component, and you just got to find the unit vector of it. Okay, so all right, we know W is this. That's W. That's the direction of W. So in order to get W, you need to move this way and then move up. Okay, so if you move that way, it's backwards from U, so it's minus U, and that direction's positive A. Okay, so W would equal A minus U. Okay, so we already got what A is. They've given us to us I plus 3J, and we want to minus U. We work that U in part A. So U is the parallel component, or the vector resolute. So that's I plus 3J minus 2I minus 2J, and you can work that out. So that's minus I plus J. Okay. And that's W. We're not done yet. It says unit vector. So you've got to do the extra step. First of all, get the magnitude of W, because we will try to find W hat eventually. So the unit vector of W will be 1 squared plus 1 squared, which equals root 2. So the unit W is 1 divided by magnitude, 1 on root 2, multiplied by W. So it's negative I plus J. And that's your final answer for the unit vector of W. So it's a bit of a tricky question. It's not just asking you for the parallel component, not parallel, the perpendicular component, but it wants you to get the unit vector of the perpendicular component. Right? So what it actually looks like is, it probably looks like a smaller version of W. So that'll be W hat. Same direction, but smaller. Okay. Question 8. Let A be points defined as AB position vectors again. So it starts at 0. Find the vector resolute A onto B, and perpendicular A perpendicular. Okay, so vector resolute A in the direction of B, and the vector component of A perpendicular to B. Okay, so it's a similar question. Well, almost the same question. You've got point A there, point B there. The vector going to A from 0 is called A, small a, and then the vector going to B is called B. And you've got a vector resolute, so again, you're going to divide A into two components. You can get a U component, parallel, and a horizontal component. Okay, so for HC, so I won't do these two because it's a very similar process. You just get what U is, and you got what W is. Now it says the shortest distance from A to OB. That's A, that's OB. What's the shortest distance? Well, the shortest distance must be the vertical distance, so the perpendicular distance. So what HC is asking you, and you can do this yourself, is you just want the magnitude of W, okay, because that's the distance, right? We don't want the vector. It says the shortest distance from A to OB. So that would be W, right? So a bit of a trick there. Question 9, A, B, C. Okay, you got A vectors A, B, C. You want to find A, B, and AC. And then I'm just looking ahead. We're just trying to find a resolute. Okay, so we'll do AB first. AB is just B minus A. So, and the position vectors again. So B minus A. I minus J. And then AC would be I minus 5J. Okay, I minus 5J. Okay, done. So what you're doing is you're projecting A B onto AC. So you've got 3 points, A B onto AC. Okay, so you're projecting that onto that. So you're just trying to find again the U component. Okay, the U component would be so the U would be given by AB dot AC. So it's just 1 times 1 is 1, negative 1 times negative 5 is positive 5 over AC times AC, AC dot AC, not times, AC dot AC at the bottom. So it's 1 times 1 is 1, 5 times 1 is 25, and then times it by AC. So that's I minus 5J. So that's a vector resolute, 6 over 26, I minus 5J. You can simplify that fraction, that's 3 over 13, I minus 5J. Okay, so C is asking you for the shortest distance from B to AC. Okay, so B to AC, again, the shortest distance from B to AC, so from here to the line AC would be the vertical distance, so you want W. Again, you can see they're trying to ask you the same question over and over again, but maybe in a slightly different way. So you want the shortest distance, so you want W. Well, W will be given by, so again, if you write it out, that's U, that's W. We'll call that AB. So W would equal AB minus U, okay? And you want the shortest distance, okay? So you're going to get the magnitude later, okay? So W equals AB. What's AB? AB was, we worked out before, at the very beginning, A part 1. I minus J minus U. Okay, minus 13 on 3 on 13. I minus 5J. Okay, I've got a suspicion that we're going to get a nasty fraction. That's all right. I'm just going to do I plus 15 on 13J. Okay, all right. So 1I minus 3 on 13I, so 1, so 13 on 13 minus 3 on 13 is 10 on 13I, minus 13 on 13I plus 15 on 13J, so that must be 2 on 13j, plus 2 on 13j. Okay, and what are we trying to do? We're trying to get the magnitude of it, because we got the vector w, so we got the vector w with the direction. We just want the magnitude of it because we want the distance. Okay, distance is an actual number. So the shortest distance would be the magnitude of w. Okay, let's work this out. Hopefully this isn't too painful. It looks a bit painful. 10 on 13 squared plus 2 on 13 squared. Okay, that's 100 on 169 plus 4 on 169. That's 104 on 169. Can we simplify that? Yes, that goes, sorry, square root of it. So that's 13 at the bottom. At the top, 4 goes into root 104 26 times. So you can write this to root 26 on 13. Okay, so that's your part C. Okay, so that's how you get the magnitude of W. Okay, for D, now they want the area of the triangle ABC. Okay, okay, if you think about it, you've got A here, you got B here, and you got C there. You want the triangle ABC. Now, what you have to do is, you've got AC. AC happens to be I minus 5j, right? And you know the magnitude of W is 2 root 26 on 13. So I won't do this, but the idea is, girls, and you know this is like the perpendicular distance, so it's the height of the triangle. So the area of the triangle is half times base times height. Okay, half times base times height. So essentially what you're going to do is you're going to get the magnitude of AC. So the magnitude of AC, I'll try to do it actually. AC is 1 squared plus 5 squared. So 1 squared plus 5 squared is root 26. Okay, so the area is half times base times height. So it's half times base. The base is the magnitude of AC, so it's root 26, times the height, which is 2 root 26 on 13. So this cancels. Let's work this out. So we've got 26 times 26. Okay, so that comes 2 times 26 on 13. All right. So what do we have? This goes into each other twice. So that's half of 4, which is 2. All right, we're done. That comes up to a nice number. So that's how you do those 3 questions. Hopefully that helps.